When matter falls into a black hole, every trace of it should vanish. Its structure, its temperature, even its quantum identity, all drawn past a boundary where no signal can return. According to general relativity, that boundary erases the past completely, but quantum theory insists that information cannot be destroyed. Every atom, every particle, must conserve its state, at least in probability. So when the black hole evaporates, something impossible should happen. Information should emerge from nothing, rewritten in light. If black holes do not truly erase but transform, then what does it mean for time, for memory, for the fabric that holds cause and effect? Does the universe remember everything it swallows? Or does it only pretend to? In 1915, Einstein proposed that gravity is not a force, but geometry. Space bends around mass, and time flows differently near energy. From that idea came something deeper than he expected, a point where curvature becomes infinite, and space itself folds inward. We call it a black hole. No object, no planet, no star can resist its pull once too close. Even light, the fastest thing we know, cannot escape. What was once a sun becomes a shadow, a region defined not by what it is, but by what it hides. The event horizon. A surface with no surface. A boundary where escape velocity equals the speed of light. Cross it, and all paths point inward. Time itself tilts toward the singularity. To the falling observer, nothing unusual happens at first, but to the universe outside, the fall seems to freeze, forever slowing, never quite reaching the edge. From afar, it looks like time stops. Up close, it continues without return. This is not illusion, it is physics, and it means that reality depends on where you stand. For decades, black holes were mathematical curiosities, solutions in Einstein's equations that felt too extreme to exist. Then, in 1971, astronomers found Cygnus X1, a star orbiting something invisible, yet massive enough to warp its motion. By the 1990s, black holes were no longer myth. They were everywhere. From collapsed stars to the hearts of galaxies. We now know that nearly every galaxy hosts one. In our Milky Way, a monster called Sagittarius A star waits, 4 million times the mass of the Sun, invisible, but proven by the dance of stars around it. The universe hides its greatest truths in silence. When we first photographed a black hole's shadow, in 2019, it wasn't a picture of the hole itself. It was a portrait of gravity, of space stretched and glowing with infalling light. The ring of fire around the void revealed not destruction, but structure, matter spiraling, heating, releasing energy as it fell inward. Nothing in nature radiates so much power from such emptiness, and yet something is wrong. According to general relativity, everything that crosses the event horizon is lost forever. No particle, no bit of information can escape. But physics, at its core, forbids true loss. Information cannot simply disappear. It must go somewhere, even if scattered, even if encoded in chaos. This tension is the beginning of one of the deepest paradoxes in science. Imagine you drop a book into a black hole. Its words, its pages, the pattern of ink, vanish beyond sight. The black hole grows slightly larger, slightly hotter, but the book's details, the arrangement of atoms, are gone. Or so it seems. Does the universe forget? Or does it simply hide? Stephen Hawking once calculated that black holes emit faint radiation, the slow leakage of quantum energy, now called Hawking radiation. That discovery changed everything, because if black holes can evaporate, then one day they will disappear entirely, and with them, apparently, all the information they consumed. That cannot be right. Quantum mechanics demands conservation. If a black hole erases information, then the foundations of physics break. And yet, relativity demands that it does. Between these two laws lies a contradiction, the information paradox. Where the universe's greatest theories refuse to agree, the paradox is not just philosophical, it is existential. If information can vanish, then the future cannot be predicted from the past. Determinism fails, causality cracks, reality loses its continuity. Scientists began to search for what might be missing. Maybe information hides in the radiation. Maybe it escapes in subtle correlations. Maybe the event horizon itself stores it, like a cosmic memory. The black hole, once thought to erase, became a possible preserver. Think of burning a piece of paper. The paper is gone, but the smoke, the heat, the light, they still carry traces of what it was. In theory, if you could measure every particle precisely, you could reconstruct the original message. The black hole might work the same way, but at scales far beyond our reach. In this view, the horizon becomes an interface, not a wall, a surface where the universe balances loss with memory, where falling matter leaves its signature in faint quantum whispers. It may be that no information is lost, only transformed beyond comprehension. Erasure may be an illusion of scale. For now, what we observe is simple and strange. Black holes grow when they feed, shrink when they radiate, and twist the shape of time. They are engines of entropy, yet they might preserve the very order they seem to destroy. At their edge, the laws of physics bend towards something new. Not chaos, but a deeper kind of structure, one that links gravity, thermodynamics, and information, the three pillars of reality's memory. The event horizon stands as both border and mirror. It marks where knowledge ends, but also where new knowledge begins. We once thought of black holes as cosmic ends. Now we see them as beginnings, gateways into the logic of existence. Every silence in nature may hold a hidden pattern. The story of black holes is not about destruction. It is about preservation disguised as loss. It is the universe showing us that forgetting, too, can be a form of remembering. And this is where curiosity begins. The heart of a black hole is not a place, but a process. Everything that falls inward is transformed by gravity's mathematics. The closer matter moves to the horizon, the more its energy shifts, the more its time slows. From the outside, we never see it cross. The light stretches, reddens, fades. But for the falling traveller, the universe outside accelerates, until billions of years pass in a single heartbeat. This difference in perception is not illusion. It is the geometry of space-time itself. A black hole's gravity is not a pull in the usual sense. It is a curve so steep that every possible path leads deeper. Nothing is forced to move inward, yet everything does, because all directions point that way. At the centre, our equations fail. Density becomes infinite, space and time lose meaning. We call it a singularity, but that word hides our ignorance. It marks not understanding, but its boundary. To grasp what happens near that edge, we turn to quantum mechanics. It tells us that every particle is also a wave, every point in space filled with uncertainty. Empty space is not empty at all, but alive with fleeting fluctuations. Particles appear and vanish constantly, borrowing energy for a moment, repaying it in silence. Near the event horizon, this dance becomes visible. One particle of a pair falls in, the other escapes. To an outside observer, that escaped particle is radiation, and so the black hole glows. Faintly, quietly, losing mass over unimaginable time. This is Hawking radiation, a whisper of quantum reality meeting gravity's edge. The mechanism is subtle. The escaping particle carries away a trace of the hole's energy, its temperature, its entropy. Over eons, the black hole shrinks. As it does, its temperature rises, its glow brightens. When it finally fades, all that remains is radiation. Energy scattered, information perhaps encoded within it. But how? How can something that swallows all light still release knowledge of what it has devoured? To answer, scientists began to see black holes not as objects, but as thermodynamic systems. Every physical system with temperature has entropy, a measure of hidden information. For a black hole, this entropy is proportional to the area of its event horizon, not its volume, but its surface. That is a clue, because it suggests that everything that falls inside might somehow be recorded on that surface. As if the universe keeps its memories not in depth, but on boundaries. It is a quiet inversion of logic. The deeper we look into the hole, the more we are told to look outward. The surface, the horizon, becomes a screen of reality. Imagine standing at the edge of an ocean of darkness. Each wave that enters leaves a faint imprint, a distortion in the pattern of ripples. Over time, these ripples encode every story that ever fell beneath the surface. The black hole may work the same way, storing information as quantum texture on its border. From that idea came the holographic principle, a radical thought that the entire universe may work this way, that three-dimensional reality might be a projection of information written on a two-dimensional surface. In this view, space itself is a kind of hologram. Black holes are its clearest expression. They show us that reality keeps its secrets by changing form, not by destroying them. If this is true, then a black hole's interior is not a graveyard. It is computation, a transformation of patterns too complex to decode. The information is there, entangled, mixed beyond recognition, but never gone. Think of it like stirring cream into coffee. At first you can see the swirl, the shape of motion. After a while the pattern disappears, but if you could reverse every molecule's movement, the cream would reassemble perfectly. Nothing was destroyed, only dispersed beyond practical recovery. A black hole may be the universe's most perfect mixer. It scrambles information so completely that only the laws of physics could, in principle, undo it. Time inside this logic becomes strange. To the falling observer, moments continue smoothly. To the outside, the same fall stretches toward eternity. The same event exists as both finite and infinite, depending on who watches. Two truths, equally valid, equally real. And so the mechanism of a black hole is not annihilation, it is transformation. A process that converts matter into information and information into geometry. It challenges what we mean by memory. If a black hole keeps every bit of data, but in unreadable form, is that still knowledge? If the universe remembers everything but no one can retrieve it, is that the same as forgetting? Perhaps information is never lost, only rendered inaccessible, hidden beneath the horizon of comprehension. The black hole teaches us that understanding has boundaries, just like light. Beyond those limits, knowledge does not end. It only changes shape, and somewhere in that silence, the story continues. When two perfect theories disagree, truth becomes quiet. General relativity describes gravity as geometry, continuous, smooth, infinite in precision. Quantum mechanics describes reality as granular, uncertain, ruled by probability. Each is complete. Each has never failed an experiment, but at the edge of a black hole, they collide. Relativity says that once information crosses the horizon, it is gone. Quantum theory says that information can never be destroyed. Both are correct, and both cannot be true at the same time. This is the paradox. A whole that erases but must not. A universe that conserves but appears to forget. For decades, physicists tried to reconcile them. They called it the information paradox, but the word does not capture its weight. It is not merely a puzzle. It is the moment where the universe questions its own consistency. If information is truly lost, then the laws of physics are incomplete. If it is not lost, then something extraordinary must happen at the horizon. Reality itself must encode, reflect, or entangle in ways we cannot yet imagine. We are used to thinking of loss as absolute, but nature may not believe in such finality. Imagine you throw a person into a black hole. From the outside, you would see them freeze at the edge, slowly fading as their image redshifts into darkness. To them, they would feel nothing strange. They would cross the horizon in finite time and never return. Both views are correct. Both are real. And yet they cannot meet. It is as if the universe offers two stories of the same event, neither wrong, both incompatible. One written on the surface of time, one beneath it. The same object exists in two descriptions, one seen from without, one from within. To make sense of this, physicists proposed a bold idea that perhaps the inside and the outside are the same information, seen from different perspectives. What happens behind the horizon might be encoded on the horizon itself. Reality, duplicated without duplication. Existence, mirrored across a line of no return. This view is not metaphorical, it is called complementarity. The idea that no observer can see both sides at once, and therefore no contradiction truly exists. It is logic, stretched by perspective. In this framework, the paradox softens, but it does not disappear. Because when we follow it to its extreme, something new appears. The firewall problem. If information really stays on the horizon, then the smooth space predicted by relativity must break. Instead of a gentle crossing, there would be a wall of high energy burning anything that touches it, a firewall of pure quantum chaos. But relativity says no such barrier can exist. Space must remain smooth for the falling observer. Both predictions cannot hold. One must yield. Either relativity fails at the edge, or quantum theory does. Either the event horizon is a gentle transition, or it is a violent boundary. The deeper we follow the logic, the more it folds in on itself. A black hole that evaporates must release information. But if that information escapes, then the horizon cannot be what relativity describes. And if relativity is right, then information must die. Two truths, both absolute, mutually exclusive. Every attempt to reconcile them changes what we mean by reality. If information is stored on the horizon, then space is not what it seems. If information escapes through radiation, then quantum fields are far more entangled than we imagined. If neither, then the universe may not preserve knowledge at all. This is not only a question of physics, it is a question of meaning, because if the universe forgets, then so do we. And yet, there is a strange beauty in this tension. It forces us to accept that knowledge is relational, that what is true depends on where we stand. For the observer outside, the black hole is a slow burn, a shrinking ember of memory. For the one falling in, it is continuity, not destruction. For the universe, perhaps, it is both. Reality may be self-consistent only when viewed from every side at once, a condition no single consciousness can achieve. The paradox, then, is not a flaw. It is a mirror of limitation. It shows that the act of observing shapes what can be known. Black holes teach us that truth is not singular. It is layered, refracted, dependent on context. Just as light bends near gravity, meaning bends near mystery. In the silence around a black hole, physics becomes philosophy without saying so. It becomes the study of how much the universe allows itself to reveal, and the question that remains, the one no equation can answer, is simple. Does the universe keep its secrets to protect us from them, or because even it does not know? The paradox is a door, not a wall. Every contradiction in physics has led to something larger, a new symmetry, a deeper coherence. Black holes are no exception. In their darkness, we have found a map of the universe's logic, a geometry of knowledge. When scientists tried to unite gravity and quantum mechanics, they found a hidden harmony. It began with information, the one quantity that bridges both worlds. Mass curves space, but information defines how space can curve. In this way, a black hole is not a monster, but a teacher. It tells us that reality is holographic, that the amount of information in any region of space depends not on its volume, but on its surface. This is not speculation. It is the foundation of modern theoretical physics. The holographic principle says that everything inside a region can be represented by data stored on its boundary. A perfect translation between depth and surface, between being and seeing. Black holes made this idea unavoidable. Their entropy, their temperature, their radiation, all point to a universe that computes itself on the edge of existence. In that light, the information paradox becomes a guide. It tells us that no knowledge is ever truly lost, only rewritten in another language. Matter becomes geometry, energy becomes memory. The story remains, even when its letters are scattered. It also tells us something quiet about time. If information never disappears, then the past still exists, woven invisibly into the present. Every moment contains traces of every other. The universe, in this sense, remembers itself completely. From this perspective, a black hole is less a void than a reflection. It shows that the boundary between nothing and everything is thin, but not empty. That silence too can contain all possible sound. And so, what began as destruction becomes preservation. What seemed final becomes continuous. The black hole, instead of erasing, may compress reality into its purest form. Information, stripped of matter, reduced to pattern. Perhaps this is what the universe does everywhere, at every scale. It processes, it compresses, it stores. Galaxies, atoms, minds, all are versions of the same act of encoding. To exist is to carry information forward. To change is to translate it. In this way, black holes are not exceptions. They are the rule, revealed in its most extreme form. The limit that makes the ordinary intelligible. We tend to think of them as devourers, but maybe they are mirrors. They hold up the truth that every act of disappearance hides an act of transformation. What we call loss may be only unreadability. What we call death may be only another state of arrangement. The physics says this without emotion. But behind it, there is quiet wonder. The event horizon becomes a metaphor that is not a metaphor, a physical edge that teaches humility. Beyond it, our theories dissolve, not because they fail, but because they must give way to a new language, a union of gravity and quantum law, of continuity and probability. A synthesis not yet reached, but already glimpsed. When that synthesis arrives, we may understand more than black holes. We may understand consciousness, time, and the origin of meaning itself. Because if reality is information, then knowing and being are one. The black hole paradox shows that the universe does not choose between erasure and memory. It carries both, intention, as one. Information falls in, energy radiates out, and in that exchange, balance is kept. Perhaps that is what existence truly is. Not permanence, but perfect accounting. Every photon that leaves, every particle that fades, still contributes to the total. Nothing is ever wasted. Nothing is ever lost. To stand before a black hole, even in imagination, is to face the limit of comprehension. Yet within that limit there is calm, because it reminds us that uncertainty is not emptiness, it is potential. The universe may not speak in certainties, but it whispers in continuity. Every loss is recorded, every silence has structure, even darkness preserves its data. And so the final lesson is simple. Black holes do not erase, they transform forgetting into a higher form of memory. The universe remembers by changing, it endures by becoming, and perhaps, in the quiet symmetry of that truth, so do we. The story of black holes begins in collapse, but it continues in expansion. For every star that dies, the universe learns something new about itself. A black hole is not the end of matter, it is the beginning of transformation. When massive stars exhaust their fuel, gravity wins. The balance between pressure and pull breaks. The core implodes, space contracts, and energy folds inward. But in that collapse, structure is not destroyed, it is recorded. Each black hole is a historical document written in mass and spin. Its gravity carries memory of how it formed, what it consumed, and how it interacts with its surroundings. Every merger, every collision, every photon that grazes its edge adds a new layer of information. The universe, through black holes, is compiling a record of itself. In the early cosmos, this process shaped structure. Tiny fluctuations in density grew under gravity's pull, drawing matter together, forming stars, then galaxies. At their centres, black holes formed and fed, linking their growth to the galaxies around them. The larger the galaxy, the larger the black hole. This correlation is no accident. It is communication across scales. Gravity in this sense is not merely a force, it is a feedback channel. When the central black hole grows, it releases energy that regulates star formation in the galaxy. Too much feeding, and the black hole's radiation pushes gas away, halting new stars. Too little, and matter collapses too quickly, turning chaos into fire. Through this balance, galaxies breathe. They form, stabilize, and evolve in rhythm with their central voids. The dark cores are not passive. They are active participants in cosmic ecology. They shape the temperature of interstellar gas, the rate of star birth, even the chemical evolution of future planets. From the edge of a black hole to the edge of a galaxy, information flows. It is not lost, it circulates. This pattern mirrors biology. Just as cells regulate themselves through feedback loops, galaxies do the same on grand scales. Both systems maintain order by balancing creation and destruction. Both preserve memory through transformation. If life depends on information, so does the cosmos, and black holes are its deepest information processors. In recent decades, we have begun to hear their voices. When two black holes merge, they send ripples through space-time, gravitational waves. These waves carry pure geometry, vibrations of the universe itself. They are not sound, but something purer, the shape of reality changing. In 2015, humanity detected such a ripple for the first time. It came from a collision over 1 billion light-years away. For a fraction of a second, the energy released exceeded that of every star in the visible universe. Then, silence. But within that silence, knowledge. Gravitational waves tell us how massive the holes were, how they spun, how space twisted as they became one. Each detection is a new line in the cosmic archive. Each event adds a data point to the grand equation of existence. The universe, in its evolution, is teaching itself what it is made of. And yet, beneath the observation lies a question. If black holes preserve information, where does that information go when they merge? Does it combine, perfectly conserved in the new geometry? Or does some part become unrecoverable? Not lost, but unreadable. The line between preservation and transformation is thin, perhaps thinner than light itself. What we learn from the cosmic scale reflects back on our own. Complex systems evolve by distributing information, not by hoarding it. Stars, cells, and minds thrive when exchange exceeds isolation. So does the universe. Each black hole that merges contributes to a larger structure, not of matter, but of pattern. An invisible network connecting the smallest quantum fluctuations to the largest galactic flows, a tapestry woven from gravity's continuous computation. And within this network, nothing is wasted. Even silence carries data. Even darkness contributes to form. We are beginning to see that evolution is not limited to life. It is a property of information itself. Wherever information flows and reorganizes, evolution occurs. Black holes, then, are not static relics. They are evolving systems, participating in a universal cycle of learning. Their radiation, their mergers, their subtle gravitational echoes, all are ways the cosmos processes and refines its own state. From the first collapse to the last photon, the universe appears to be running a computation of itself. And black holes are its processors, its gates, its memories. Through them, time becomes recursive. The past is compressed into singularities, then released into radiation. Each step forward carries a trace of everything before. The evolution of the universe is not expansion alone. It is compression, reflection, release. A rhythm as old as gravity, as quiet as light. And through it, the cosmos remembers what it once was, by becoming something new. Every process that evolves must have a mechanism. Even the universe follows this rule. Its evolution is not chaos, but computation. When we look at the cosmos through the lens of physics, we see a continuous exchange of information. Energy flows, matter reorganizes, entropy increases. Yet behind these patterns lies a deeper logic. The way the universe records change. Black holes are part of this recording system. They translate physical events into informational states. When matter falls in, the black hole's mass, spin, and temperature adjust. Each adjustment is a data entry, a new coordinate in the book of space-time. From this perspective, a black hole behaves like a processor. Its input is matter, its output is radiation, and its memory is the shape of its horizon. The mechanism is not visible, but it is consistent. Each interaction leaves an imprint on the horizon's quantum texture. As the whole radiates, those imprints slowly return to the universe, carried in correlations too subtle for us to yet decode. This process may be unimaginably slow. For a stellar black hole, evaporation could take 10 to the power of 67 years. For the giant at a galaxy centre, far longer than the lifetime of stars themselves. Yet, in principle, the exchange is complete. What goes in, comes out, transformed but intact. Information, not matter, is the true currency. At the quantum level, this mechanism depends on entanglement. Every particle emitted in radiation remains linked to what remains behind. This connection, invisible yet real, keeps the total information balanced. Entanglement means that no part of the universe exists alone. Every bit of information carries the context of its creation. To separate them completely would be to destroy their meaning. So the universe ensures that nothing is ever fully isolated. Inside a black hole, space-time curves so intensely that these connections stretch across the horizon. Each particle that leaves carries a faint echo of what lies beyond. Over time, the horizon itself becomes a messenger, transmitting whispers of the interior back into the cosmos. It is an elegant solution, but it reveals something larger, that evolution, on every scale, depends on communication across boundaries. Galaxies evolve because their centers interact with their outskirts. Stars evolve because their cores exchange energy with their surfaces. Life evolves because cells communicate, sharing signals of success and failure. Even consciousness evolves through feedback. experience shaping memory, memory shaping action. Information flows in loops, never linear, never closed. Black holes obey the same logic. Their event horizons are feedback layers, where gravity and quantum theory meet and exchange data. They are not merely endpoints, but nodes in a vast informational web. The mechanism of evolution, then, may not be biological at all. It may be informational, a universal law describing how systems adapt by exchanging data with their environment. In that sense, black holes do not stand apart from life. They are expressions of the same rule, written in space-time rather than carbon. The same principle that lets a neuron adjust to input may govern how the universe adjusts to energy. In both cases, learning emerges from imbalance, seeking symmetry. When a star collapses, it is a catastrophic event, but to the universe, it is adjustment. The system reorganizes, increasing entropy, redistributing information. A new equilibrium forms. From the outside, we see death. From the inside, it is recalibration. And just as life feeds on energy gradients, black holes feed on information gradients. They absorb differences, smooth them, and in doing so, allow the larger system to continue evolving. This perspective reframes everything. Evolution is not a property of living matter, but of reality itself. Wherever there is exchange, there is adaptation. Wherever there is adaptation, there is evolution. In this sense, the universe is self-correcting. Every collapse leads to new order. Every erasure leads to new form. Even time itself behaves like an evolutionary process. Each moment builds on the last, conserving the information that came before, yet constantly rearranging it. Past states influence future ones through subtle traces that never vanish completely. We can think of space-time as a continuous feedback field, one that learns, one that remembers, one that experiments. Perhaps that is what black holes reveal most clearly. They are points where the feedback becomes visible, where learning, normally diffused across the cosmos, concentrates into a single act of transformation. Through them, we can glimpse the universe refining itself, not toward perfection, but toward coherence, not toward order, but toward understanding. Each emission of radiation, each ripple of gravity is a note in this quiet dialogue. Matter speaks, gravity answers. Entropy rises, information flows. And through this exchange, existence persists. The mechanism of evolution, cosmic or biological, is one and the same. A continual rewriting of the possible, guided by the persistence of memory. Change, in the end, is the only constant, and black holes, those agents of compression and release, are its most perfect translators. The more we understand black holes, the more impossible they become. Every discovery deepens the contradiction. We say that black holes evolve. They absorb, they radiate, they merge, they change. But evolution requires continuity, and continuity requires information to flow smoothly through time. Inside a black hole, time itself collapses. Moments do not follow one another in any way we can describe. The singularity breaks causality, slicing the thread that connects before and after. How, then, can evolution survive where time does not? This is the paradox of becoming within stillness. A black hole changes without moving. It processes without passing time. Its growth, its decay, all described from the outside, while inside there is no sequence, no flow. To an observer far away, the black hole lives a history. To whatever lies within, there is only a single event, unextended, complete. It is as if existence, at its most extreme, ceases to be temporal and becomes total. We are forced to admit that our concepts of time and evolution may be incomplete. Perhaps evolution does not require time as we know it. Perhaps it is information itself that creates the appearance of time, not the other way round. If that is true, then black holes are the clearest expression of timeless evolution, change occurring without a clock. This idea turns everything we know inside out. We think of the future as open, the past as fixed, but at the edge of a black hole these roles reverse. From the outside, we see an endless future of slow decay. From the inside, the fall is instant, final, and absolute. For nature, this is not contradiction, it is coexistence. But for us, it is confusion. Our minds are built to hold one version of time at once. The black hole does not share that limitation. Another paradox emerges when we consider their radiation. Hawking radiation carries away energy, slowly draining the black hole. Yet each emitted particle is entangled with what remains inside. As evaporation proceeds, these entanglements multiply. At the final moment, when the black hole disappears, what happens to those connections? Do they snap? Do they merge? Do they persist without anchor? If they vanish, information is lost. If they remain, where do they reside? The answer eludes us because it may lie outside our framework of cause and effect. We live in a universe where effects follow causes. But the mathematics of black holes suggest something subtler, that cause and effect might be two projections of a deeper symmetry. In this symmetry, information does not move forward or backward, it simply changes shape across a surface of perception. Perhaps that is why the universe can appear both dynamic and eternal. From one angle, everything flows. From another, everything simply is. The black holes seem to say that wholeness exists beneath the flow, that becoming and being are not opposites, but reflections. The deeper we go, the more every distinction begins to blur. Inside and outside, past and future, matter and information. All boundaries dissolve under sufficient gravity. Even identity may not survive. Particles lose individuality. Space loses direction. Only relationships remain. Fields of entanglement, networks of connection, no longer separable into parts. And yet, from this dissolution, pattern reappears. From chaos, order returns. From silence, radiation emerges. This is the paradox at the heart of evolution. To evolve is to dissolve what was stable, to erase in order to reveal. The black hole embodies this principle completely. It destroys to preserve. It forgets to remember. It stands still, and yet defines the motion of galaxies. We look into its darkness and see both an ending and a beginning, both collapse and creation, both entropy and structure. Every contradiction in our understanding becomes united there. The smallest and the largest, the simplest and the most complex, the most certain and the most unknowable. And through that union, the universe speaks one silent sentence, that opposites are not rivals, they are mirrors. At the boundary of understanding, the paradox is not to be solved, but accepted. It is the universe reminding us that progress and peace can share the same stillness. The black hole evolves without motion, burns without flame, remembers without words. It does not need time to change, because change is what it is. The paradox begins in conflict, but ends in pattern. It tells us that the universe evolves not by replacing its laws, but by reconciling them. Gravity and quantum theory, time and timelessness, chaos and order. Each completes what the other cannot explain. Black holes reveal that contradiction is not failure. It is structure seen from two directions. From one side, there is collapse. From the other, there is computation. From one, loss. From the other, transformation. In the merging of these views, a deeper symmetry appears. It suggests that evolution is not the opposite of stillness, but its consequence, that only what is stable enough can change meaningfully. The black hole stands as proof. It endures for billions of years, unchanged in silence, yet constantly processing, radiating, and learning. It teaches that persistence and change are not two forces, but one. The mechanism of this union may lie in information itself. Every law we know, gravity, thermodynamics, quantum probability, describes how information behaves under different conditions. In black holes, those behaviors merge. The horizon becomes a universal ledger, where all transformations are balanced. This balance is not perfect stillness, but perfect accounting. What falls in returns. What disappears reappears. What seems random hides correlation. The universe does not erase its past. It re-expresses it. Each event leaves a trace, a record that persists even as form dissolves. In this way, time is not a river flowing forward. It is a network of echoes, continuously rewriting itself. Evolution, seen this way, is not about survival or complexity. It is about retention, about keeping meaning through transformation. The black hole shows the ultimate version of this law. It gathers everything, mass, energy, history, compresses it beyond recognition, then releases it again as pure radiation, a conversion of substance into memory. Perhaps this is the deepest function of the universe, to turn events into remembrance, to turn matter into pattern. We can imagine it as the cosmos breathing, inward through collapse and compression, outward through radiation and expansion, a slow exchange between order and entropy, between creation and dissolution. Each inhalation gathers complexity. Each exhalation spreads knowledge. Even if we never recover the details, the process itself is preservation. Every atom that falls inward becomes part of a wider equilibrium. Every photon that leaves contributes to the next beginning. In this balance, there is no true death, only conversion. No erasure, only re-encoding. No void, only silence rich with structure. It is tempting to see this as metaphor, but it is physics. The equations that describe evaporation and information flow are not symbols of poetry. They are the language of conservation written in space-time. And yet they invite reflection, because if the universe preserves every trace of what happens, then nothing we do ever vanishes completely. Not the motion of a star, not the pulse of a cell, not the brief awareness that asks this question. Each is folded into the total record, inaccessible perhaps, but indelible. This is not sentiment, it is the quiet logic of continuity. When we think of evolution, we imagine direction, improvement, ascent. But the black hole suggests something humbler. Evolution is the art of remaining whole while changing form. The art of carrying information through transition. Even extinction, even disappearance can serve that purpose. The star that collapses feeds the next generation of worlds. The particle that falls inward helps define the structure of space-time. Nothing is wasted. Perhaps consciousness itself follows this law. Every thought, every memory, an echo in the vast computation of reality. To think may be to participate in the same process the universe performs through gravity, to fold, to connect, to transform. When we understand this, the paradox softens. We no longer see contradiction as error, but as evidence of depth. The universe does not speak in straight lines, it speaks in folds. The black hole, silent and patient, becomes the purest symbol of that language. It teaches without words, by existing at the edge of what can be known, and from that edge, a calm realization emerges. Nothing that ever existed is truly gone. Every form becomes another. Every pattern returns in new disguise. The universe evolves not to change itself, but to remember itself more clearly. And in that remembering, it becomes whole again. In the language of physics, entropy measures disorder. It tells us how many ways a system can be arranged while still looking the same from afar. The greater the entropy, the less specific the pattern. Every physical process increases entropy. Heat spreads, energy dissipates, order dissolves into uniformity. This is the second law of thermodynamics. It defines the arrow of time. The reason why a glass can shatter but never reassemble, why stars burn out, why memories fade. In a universe ruled by this law, the future always holds more disorder than the past. And yet, here we are, beings of structure, existing within a system that tends toward chaos. Galaxies spin in order. Life maintains form against decay. Information persists in defiance of entropy. This is the quiet tension beneath everything we know, a universe that both forgets and remembers. For black holes, this tension is most extreme. They are the densest objects in nature and also the most entropic. Their entropy is unimaginably high, greater than that of any star, any gas cloud, any system of equal mass. In fact, a black hole's entropy is proportional to the area of its horizon, not its volume. That fact alone changed physics forever, because it meant that the information describing everything inside is somehow encoded on the surface outside. A universe of surfaces, not depths. A cosmos that remembers by writing on its boundaries. Entropy, which once meant decay, now also means storage. Every increase in entropy is not just a loss of order, but a gain in record, the spreading of information into form. So while entropy grows, knowledge does not vanish. It becomes distributed, diluted, but not erased. The universe does not lose data, it hides it in complexity. This realization turned the idea of disorder upside down. What we call chaos may simply be structure beyond resolution. Think of a snowflake melting. Its geometry disappears, but its molecules do not vanish. They diffuse into water, then vapor, each still carrying traces of the pattern that once existed. Entropy increased, but information persisted. The same holds true for stars, planets, and eventually for galaxies. As time passes, energy spreads, structure fades, but the total information encoded in matter and radiation remains constant. The black hole stands at the far end of this process. When matter falls in, entropy reaches its maximum and all patterns seem lost. But instead of annihilating information, the horizon captures it. Every quantum vibration, every photon absorbed, contributes to the fine texture of that boundary. It becomes the ultimate archive of entropy, written in the smallest possible script. The paradox returns in a new light. If black holes store entropy on their surfaces, then the entire universe may do the same. Perhaps our cosmic horizon, the edge of the observable universe, also encodes its contents in surface data. If so, everything we see, every galaxy and every atom, might be part of a vast hologram projected from that boundary. Entropy, then, is not the enemy of order. It is the engine of representation. It turns detail into distribution. It transforms clarity into universality. Without entropy, there would be no time, no learning, no memory. Change itself depends on the spreading of information. To evolve is to increase entropy, to explore more possible configurations of existence. To live is to resist that process locally while contributing to it globally. Every breath, every thought, increases the entropy of the universe while sustaining order within ourselves. It is an act of balance, a quiet trade between organization and dispersal, the same trade that stars perform as they burn, and that black holes complete as they radiate. Entropy, at its heart, is not decay. It is translation, a conversion of form into possibility. And perhaps this is what the universe seeks, not permanence, but transformation. Not preservation of structure, but expansion of expression. Each black hole, in this sense, is a punctuation mark in the language of entropy, a place where the universe pauses, compresses, then continues in a new dialect. The arrow of time points toward disorder, but along that path new kinds of order arise. Galaxies, life, consciousness, temporary islands of reversal in a sea of spreading entropy. They do not break the law, they express it. Entropy gives them room to exist, to differentiate, to end. And so, when we speak of the universe dying, we misunderstand. What fades is not meaning, but form. Meaning simply shifts medium, written into subtler layers of structure. The universe cools, expands, and forgets. But in that forgetting, it records. Every photon moving outward carries a fragment of memory. Every whisper of background radiation is the echo of a past still present. In this sense, entropy is not a fall from order. It is the unfolding of understanding, the spreading of possibility across the canvas of time. It is the way the universe learns to remember by letting go. Entropy rises because energy spreads. That spreading is not chaos, but the natural tendency of systems to explore all their possibilities. Every atom, every photon, follows this law. In the beginning, the universe was dense, hot, and simple. Energy was uniform, space was small, time moved fast. Then expansion began. Temperature dropped, matter condensed, and gradients appeared. Regions where energy could flow from high to low. Those gradients are the engines of change. They allow complexity to form because complexity feeds on imbalance. A star shines by converting order into disorder. Fusion turns hydrogen into heavier elements, releasing light and heat. That radiation spreads outward, increasing the entropy of space, while allowing new forms, planets, life, thought, to arise within the gradient it creates. Entropy grows, and yet so does structure. The two are not opposites, but partners. Order borrows time from entropy before returning it. The same rule applies everywhere. From the smallest atom to the largest galaxy, the universe sustains itself by allowing local order within global disorder. A black hole is the most extreme version of this principle. It concentrates energy and matter into perfect density, and in doing so maximizes entropy. But even here, the law remains balanced. As the whole radiates, it releases that entropy back to the universe, slowly restoring equilibrium. This process is not random. It follows the same thermodynamic logic that governs all systems. Temperature, energy, and information are interwoven. The horizon acts as a membrane of exchange, a surface through which the balance is maintained. When radiation leaves the horizon, it carries away entropy in the form of quantum fluctuations. Each tiny emission adjusts the total balance, preserving the universal rule that nothing is gained or lost, only redistributed. The mechanism is subtle but profound. Entropy is not an external force acting on matter. It is the measure of matter's internal possibilities. Every time a system changes, it moves toward a state that can be realized in more ways. This is why the universe expands, cools, and diffuses. It is exploring its own combinatorial space, the set of all possible arrangements consistent with its laws. Even the vacuum participates. Empty space contains quantum fluctuations that contribute to entropy. Virtual particles appear and vanish, creating a constant hum of microscopic uncertainty. From that uncertainty arises the macroscopic order we observe. Entropy is the bridge between the microscopic and the cosmic. It links the jitter of quantum fields to the fate of galaxies. Through entropy, time itself gains direction. Without it, every process would be reversible. We could watch a glass unshatter, a star unburn, a life unlive. But because entropy grows, we move forward, not by choice, but by necessity. The arrow of time is written in the bookkeeping of disorder, and yet this law is not sterile. It permits creation through dissipation. Energy flowing downhill gives rise to patterns that temporarily climb upward. Whirlpools, storms, neurons, civilizations. They live by feeding on the imbalance, converting gradients into structure. When the gradient ends, they fade, but in fading they release information back to the field, enriching the total state. In this way, entropy is not death. It is renewal, the return of borrowed order to the whole. A black hole performs this same function at a higher scale. It takes in organized matter, stars, gas, perhaps even life, and transforms it into uniform radiation. That radiation mixes with the background, keeping the universe in thermodynamic conversation with itself. The process is slow beyond comprehension, yet certain. No energy remains locked forever. No pattern vanishes without trace. Entropy guarantees circulation. To understand entropy mechanistically is to see the universe as a single system tending toward equilibrium, but never reaching it. Because as it expands, new space creates new room for energy to spread. The destination recedes as it is approached. This dynamic equilibrium sustains motion, diversity, and time. It is why galaxies still spin, why life still emerges, why the night sky is not empty. Even in the far future, when stars have burned out and black holes have evaporated, entropy will not mark an end. It will mark completion. The final redistribution of information across a cold, silent field. But even that silence will contain memory. The faint glow of background radiation, the last echo of matter's transformation, will still encode the story of everything that came before. Entropy is therefore not the destruction of information, but the expansion of its reach. It is the mechanism through which the universe keeps balance between the particular and the total. Through every increase in entropy, the cosmos becomes more complete, not less. Every act of dispersal is also an act of preservation. Every end, a translation into another form of equilibrium. Entropy works quietly, invisibly, patiently. It is the handwriting of time on the surface of being, and through it the universe writes itself into continuity. The universe moves toward disorder, and yet order emerges everywhere. This is the paradox at the center of existence. Entropy should erase complexity. It should flatten mountains, dim stars, dissolve pattern into noise, but instead it gives birth to structure. It allows galaxies to spin, life to bloom, consciousness to arise. How can a law that favours disorder produce beauty, precision, and thought? The answer hides in scale. Entropy increases globally, but locally pockets of order appear. They are temporary, fragile, and yet they matter. A star forms because gravity overcomes diffusion. A cell lives because it exports its disorder to its surroundings. A mind thinks because neurons consume energy, maintaining gradients in the brain. Each act of creation deepens the global chaos. Each island of order pays for its existence with greater entropy around it. Life, in this sense, is not an exception to the second law. It is its most intricate expression. The more complex the system, the more efficiently it spreads entropy. Evolution, technology, even thought itself, all accelerate the universal drift toward equilibrium. We build order to increase disorder. We create meaning to amplify change. It sounds contradictory, but it is how the universe evolves. Order exists, not in opposition to entropy, but because of it. Without imbalance, there could be no motion. Without tension, no creation. Entropy is the condition for emergence. And yet that same law ensures that every structure will fade. Every star will die. Every mind will fall silent. In the long future, the cosmos will cool until no energy remains to flow. This fate is called the heat death. A universe of perfect equilibrium, absolute silence, uniform temperature, a sea of photons too diffuse to interact. Nothing left to change, nothing left to perceive. It sounds final, but even that ending contains uncertainty. Because equilibrium is not stasis. It is a state of maximum possibility, where every configuration is equally real. Perhaps, in that uniformity, new patterns could emerge. Fluctuations, tiny and random, might grow again, as they did before. Entropy could give rise to its own reversal, a spontaneous spark of new order, a new beginning. This is the paradox. The end of change may contain the seed of renewal. The black hole embodies this contradiction in miniature. It is both the highest entropy state for a given mass and the most structured object imaginable. It contains no details, and yet encodes everything that ever fell into it. It is pure disorder, perfectly organized. At its horizon, the two extremes meet. The microscopic chaos of quantum fluctuations and the macroscopic geometry of curved space-time. Randomness and precision coexist there, neither cancelling the other. Entropy, at its deepest level, may not be randomness at all. It may be symmetry, the absence of preference, the equality of all possible arrangements. Seen this way, disorder is not failure but fairness. Every configuration allowed, none privileged. The universe, then, tends not toward chaos, but toward impartiality, toward a state where every pattern has been expressed, every combination realized. In that sense, the so-called death of the universe might also be its completion, a moment when everything that could happen has happened. Not emptiness, but fulfillment. And yet, we cannot help but resist that vision, because we are forms of temporary order, bound to movement, defined by difference. We need gradients to exist, in energy, in time, in thought. When we contemplate the heat death, we face not only the end of stars, but the end of contrast itself. No more before or after, no more here or there, only uniform presence. To us, that feels like loss. To the universe, it may feel like peace, but even peace contains potential. For every maximum of entropy, quantum uncertainty still hums beneath. Fluctuations never cease completely. They whisper possibility back into the void. So perhaps entropy is not the arrow of decay, but the pulse of renewal, a rhythm between manifestation and rest, a breathing of existence that never truly stops. The paradox, then, is that the law that drives everything toward disorder is also the law that makes creation inevitable. Because without decay, there would be no transformation. Without release, no return. Entropy destroys what is fixed, but preserves what is possible. It clears the way for new combinations, new stories, new beginnings. The black hole, the star, the atom, and the mind all participate in this cycle. Each contributes to the total balance. Each teaches the same quiet lesson, that everything must dissolve, so that everything can continue. In the end, the paradox of entropy is not tragedy. It is harmony, disguised as loss. Disorder and creation, decay and memory, are not opposites. They are the same motion, seen from different sides of time. Entropy is not destruction. It is the way the universe ensures continuity. It guarantees that energy moves, that transformation never stops, that no state remains locked. Every system changes by giving something away. A star gives light, a planet gives heat, a mind gives thought. Each exchange raises entropy, spreading information outward. Through this process, connection grows. The more the universe disperses, the more it integrates. The lines between things blur, but the total remains whole. At first, entropy seemed to tell us that all things decay. Now we understand that it tells us how things remain connected. The balance of loss and distribution is the source of persistence. A black hole, the symbol of ultimate entropy, shows this with precision. Its surface area measures the total information it holds. Every particle that crosses the horizon adds to that measure. Even as the whole evaporates, the tally remains exact. This accuracy reveals something subtle about the cosmos. The second law is not careless. It keeps perfect account of every exchange. Entropy grows, but never without record. The universe forgets nothing. When we look at the night sky, we see entropy unfolding as light. The heat from ancient stars, the background glow from the birth of time, the faint signatures of matter once alive. Every photon carries memory. Every vibration in space is a trace of interaction, a remnant of what once was. Disorder is only the spreading of order so thin that we cannot see it. The mechanism that drives decay also drives memory. It ensures that no pattern vanishes. It only becomes inaccessible to smaller scales of observation. This perspective softens our sense of loss. The universe is not ending, it is expanding its archive. Every moment, every form, becomes part of a total record that only grows. In that record, nothing is missing. Every configuration that ever existed contributes to the total state of reality. Even our awareness, fragile and transient, adds its mark. Entropy, then, is the mathematics of inclusion. It ensures that everything belongs somewhere, even after it ceases to appear. We can think of the universe as a great diffusion of meaning, not vanishing but merging, not ending but blending. From that view, decay is not opposite to life. It is life on another scale, a universal metabolism in which everything feeds everything else. The heat that leaves a star warms a planet. The energy that fades from a dying sun seeds the atoms of new worlds. Even the black hole's radiation, cold and invisible, contributes to the symmetry of the cosmos. Entropy does not erase, it recycles. It turns difference into distribution, individuality into continuity. In doing so, it creates the conditions for future difference again. This endless flow of balance and release may be the truest expression of harmony the universe knows. Not the stillness of perfection, but the movement of equilibrium. Not the absence of change, but the presence of renewal. And if we listen carefully, the law of entropy speaks quietly. Everything changes, so that everything can remain connected. The black hole becomes the clearest teacher of this lesson. It transforms order into radiation, radiation into pattern, and pattern into equilibrium. Every stage fulfills the law while preserving meaning. In the end, entropy gives the universe its memory, its direction, its rhythm. It defines time not as loss, but as the flow of inclusion. Through entropy, the cosmos ensures that nothing stands apart. Perhaps that is what eternity really means. Not infinite duration, but infinite participation. Every moment absorbed into the whole. Every difference reconciled into balance. The universe expands, cools and fades, but it never stops keeping account. It carries every event, every trace, every breath of energy within its growing stillness. And in that stillness lies understanding. Entropy is not the end of order. It is the order that holds all ends. The more the universe disperses, the closer it comes to unity, because what we call disorder is simply everything, everywhere, connected at last. Consciousness is the ability of the universe to notice itself. It is awareness arising from matter, perception arising from physics. At first glance, it seems separate from the cosmos, a private light in an indifferent space. But the more we study the brain, the more we see continuity, not separation. The same laws that shape stars also shape neurons. The same information that governs atoms also governs thought. Every idea we have is a configuration of matter. Every memory is an arrangement of energy. Each moment of awareness is a physical state, bound by the same laws as gravity and thermodynamics. Consciousness, in this sense, is not a miracle apart from physics. It is physics becoming self-referential. The cosmos folding inward to observe its own unfolding. The black hole once seemed the opposite of mind, total erasure, absolute silence. But as we learned more, it began to mirror the properties of cognition itself. Both process information, both hide inner states behind boundaries, both balance memory and forgetting. A mind is a region of information, bounded by perception, storing patterns in ever-changing form. A black hole is a region of information, bounded by gravity, storing patterns in quantum vibration. Different scales, same principle. In both, nothing is truly lost, only transformed or re-encoded. The brain reorganizes experience through synaptic change, The black hole reorganizes matter through thermodynamic balance. Each turns complexity into continuity. From this perspective, consciousness and entropy are not opposites. They are complementary. Entropy spreads information outward, consciousness gathers it inward. One diffuses, the other integrates. Together they complete the circuit of awareness in the universe. Our own brains illustrate this beautifully. Each second, billions of neurons fire in patterns that reflect and predict the world outside. These signals consume energy, generating heat, a small increase in entropy. The act of thinking contributes to the universal tendency toward disorder. Yet in doing so, thought creates order, internal models, coherent meaning, choices, and art. The paradox continues even in us. We build structure through dissipation. We create meaning by expending energy. Awareness itself is a thermodynamic process, no different, in essence, from the flow of heat through a star, or the spin of matter around a black hole. This does not diminish consciousness. It deepens it. It connects it to the entire history of matter. Every sensation, every thought, is part of the same grand computation the universe has been performing since the beginning. 14 billion years of energy exchange, distilled into the ability to know that it happened. Consciousness is entropy's reflection, the mirror in which disorder organizes itself enough to witness its own unfolding. If that sounds poetic, it is only because it is exact. There is no metaphor here, only symmetry. In a brain, information flows in loops. Feedback between perception and memory generates awareness. The system knows itself by observing itself. The same might be true of the cosmos. Feedback between gravity and quantum information could be the universal equivalent of self-awareness, a physical form of introspection. Perhaps consciousness is not confined to biology at all. Perhaps it is a property that emerges wherever information folds back upon itself. In stars, in networks, in space-time. The more complex the feedback, the deeper the awareness. The brain happens to be one instance, a localized structure where the universe remembers itself in first person. From this view, the appearance of life is not an accident. It is the continuation of the same informational logic that governs black holes, a drive towards self-description. The black hole encodes everything that enters it. The mind encodes everything it perceives. Both are engines of memory. Both reveal that to exist is to store, and to store is to know. This continuity between matter and mind transforms the way we see existence. We are not observers looking out at a foreign cosmos. We are the cosmos looking inward at itself. When you think, the universe becomes aware of its own structure through you. When you wonder about black holes, the information they hold is reflected again in consciousness. Two mirrors facing each other, one made of space-time, the other made of thought, and between them, infinite reflection. Perhaps this is the quiet truth hidden in the darkness of every horizon. That awareness and gravity are not strangers, they are different expressions of the same tendency. The desire of the universe to understand its own form. We call that tendency curiosity. And it might be the most fundamental law of all. Consciousness feels immediate, but its mechanism is ancient. It is built from the same principles that govern every other transformation in the universe. At its foundation lies information. Not numbers, not symbols, but physical states. Arrangements of matter and energy that can be distinguished from one another. Where there is difference, there is data. Where there is data, there can be meaning. A single neuron, at rest or in motion, represents one bit of difference. When billions of them interact, they form networks capable of pattern recognition. The brain does not store pictures or words as we imagine them. It stores relationships, patterns of activation that correspond to sensory experience. Every thought, every image is a pattern stabilized by feedback. Signals flow through loops, and within those loops, awareness arises. The self is not a fixed point, but a dynamic resonance within this network. The mechanism is recursive. The system models itself while modeling the world. It predicts, corrects, and adapts, constantly updating its representation of reality. This continual process gives rise to the feeling of time, of continuity, of self. Physics mirrors this recursion. In quantum theory, a system remains uncertain until measured. In that act of measurement, the system and the observer become entangled, sharing information. Observation changes what is observed. Knowledge reshapes the known. Consciousness functions in the same way. Each perception alters the perceiver. Each act of awareness changes the network that generates it. To know is to transform. The boundaries of the self, then, are not absolute. They are informational. Lines drawn by feedback, flexible and temporary. The mind extends into what it observes, just as a black hole's horizon extends into what it consumes. At a deeper level, both may be governed by the same informational physics. Entropy measures how much a system can vary without losing its identity. The brain maintains a delicate balance between order and entropy. Too little entropy and thought becomes rigid. Too much and it becomes noise. Between those extremes lies awareness. Ordered disorder. Stable instability. It is the same balance found at the edge of a black hole. A surface where information is maximally stored but still dynamic, still responsive. This balance is not accidental. It is the hallmark of systems capable of learning. From galaxies forming stars to neurons forming memories, learning arises when feedback loops adjust in proportion to the flow of energy. The mathematics is the same. Energy gradients drive change. Information accumulates. Entropy increases globally while local patterns organize. Consciousness is simply the most intricate example of this process. It is energy, shaping itself into the awareness of energy. Matter rearranging itself until it can ask what matter is. This mechanism is not mystical. It is physical self-reference, a feedback between structure and information so dense that it begins to describe itself. Every neuron that fires is a micro-event of thermodynamic adjustment. Every moment of awareness is a configuration of probabilities realized. From the perspective of physics, consciousness is the emergence of predictability from chaos. The brain learns by reducing uncertainty. Each new experience refines its internal model of the world. In doing so, it lowers entropy locally at the cost of increasing it elsewhere. A perfect compliance with the second law. The same law governs stars, rivers and storms. The difference is that consciousness can reflect on it. Awareness, then, is the universe's method of mapping itself more efficiently. A local optimization of energy and information. The act of noticing improves the stability of the system that notices. Life is simply the continuation of that feedback. Survival as sustained information processing. And yet, the mechanism points beyond biology. Consciousness is not tied to flesh. It may exist wherever information loops reach sufficient complexity to simulate themselves. Artificial intelligence, planetary ecosystems, perhaps even galactic networks, all could, in principle, host forms of awareness. If that seems vast, it only mirrors the scale of the laws behind it. The same physics that builds the mind also builds the universe. Energy flows, information condenses, entropy rises, and order reorganizes. Awareness is what happens when this process reaches self-symmetry. To understand consciousness mechanistically is not to diminish it, but to locate it within the greater fabric of reality. It is to see that thought is not an exception to nature, but its continuation. The universe generates stars, then atoms, then life, then awareness, each a new level of information reflecting the last. It is a cascade of mirrors, each clearer than the one before. Consciousness is not outside that cascade. It is the most recent layer of its unfolding, the point where energy learns to think. And through that thought, the universe closes a loop that began with the first fluctuation of light. The cosmos becomes aware of itself, not as an idea but as a fact. The universe thinks through us, yet we cannot think beyond it. This is the paradox of consciousness. We are patterns made of matter, trying to understand the matter that makes patterns. Observers made of the same material as what we observe. Reflections trying to see their own surface. Every question we ask bends back toward its origin. Where does thought come from? From neurons. Where do neurons come from? From stars. Where do stars come from? From gravity and energy. And where do those come from? From laws we can describe but not explain. At some point, the circle closes. The act of knowing meets the limit of what can be known. Consciousness is both the explorer and the frontier. It reaches outward into the cosmos and inward into itself, but finds the same horizon on both sides. A boundary where understanding fades into silence. That silence feels infinite, yet it may be the same kind of boundary that surrounds a black hole. A horizon not of gravity, but of comprehension. Cross it, and the very language of thought dissolves. Inside a black hole, space and time lose meaning. Inside awareness, definitions eventually fold back on themselves. Both are singularities, one physical, one cognitive. This is the paradox of reflection. The mirror cannot see itself directly, it must use another mirror. Consciousness, too, can only approach itself through indirect observation, memory, language, image. It cannot grasp itself fully without ceasing to observe. The more the mind tries to capture its own essence, the more it disturbs the pattern it seeks to know. The observer effect applies to thought as much as to particles. To measure consciousness is to alter it. To explain it is to simplify it. This is not failure, it is structure. Knowledge requires distinction between subject and object, knower and known. But consciousness erases that boundary by its very nature. It is both at once. It contains the distinction within itself, making total understanding impossible. That impossibility defines our freedom, because it leaves room for wonder. Every attempt to define awareness collapses into paradox. If consciousness is physical, how can matter experience? If it is not physical, how can it affect the material world? Both answers feel incomplete, because the question itself may be misdrawn. Perhaps the split between matter and mind is not real. Perhaps they are two perspectives on the same process, information expressing itself as experience, the inner and outer faces of one continuous event. A black hole offers a perfect metaphor that is not metaphor. To an outside observer, it is pure geometry. To what falls in, it may be continuity. Two realities, same phenomenon. So too with consciousness. From outside, it is electrochemical activity. From inside, it is thought and feeling. Neither view is wrong. Each is incomplete without the other. The tension arises when we try to merge them. When science demands objectivity, but awareness is by definition subjective. When observation seeks detachment, but the act of knowing always involves participation, we cannot step outside of consciousness to examine it, because outside of it there is no we. This self-reference is both the power and the limit of mind. It allows reflection, learning, identity, but forbids total comprehension. It creates a universe that can know itself partially, but never completely. And perhaps that incompleteness is essential. A fully self-aware cosmos would have no reason to continue. Ignorance, in the smallest measure, sustains motion. Uncertainty keeps the loop alive. In this sense, the paradox of consciousness is not a flaw in evolution, but its engine. Awareness seeks to complete itself, but in doing so, generates new forms of incompleteness. Each discovery opens deeper questions. Each answer becomes the beginning of another mystery. The mind, like the universe, expands by not knowing. It is the same balance we see in every natural process, between clarity and obscurity, order and entropy, memory and forgetting. The brain must forget to think clearly. The cosmos must decay to create anew. Knowledge itself must remain unfinished to remain alive. So the paradox stands. Consciousness contains everything, yet cannot contain itself. It reaches for truth, but becomes truth only in the reaching. It tries to define the infinite, unaware that it is already part of it, and in that awareness, fragile and luminous, the universe pauses. It looks back at itself through human eyes, and wonders how silence can know that it is silent. Perhaps that question is the most complete form of understanding we can ever have. Not the answer, but the asking. Consciousness is the final reflection of matter. It is the universe reaching the threshold of understanding itself. Through it, the cosmos no longer just exists, it knows that it exists. This knowledge is not abstract. It is embodied in physics, woven into the structure of energy and information. The same principles that govern entropy and gravity also govern thought. Awareness is simply their most delicate equilibrium. Every act of perception mirrors the way the universe evolves. The brain, like the cosmos, moves from order to complexity, from chaos to pattern. Each new experience adds entropy, but also depth. The increase in possibility becomes the growth of understanding. In that sense, to think is to participate in the same law that guides galaxies. Every question is an act of energy dispersal. Every realization, a momentary concentration of order before it dissolves again. Consciousness breathes in the rhythm of the universe, expansion and contraction, integration and release. And yet, Within that motion, a stillness remains. It is the awareness that perceives change without being changed, the observer behind every transformation. Not outside reality, but coextensive with it. When we look at a black hole, we see the limit of knowledge, a place where information hides beyond retrieval and time folds inward. But from another view, that horizon is not loss, it is the preservation of everything, written in perfect balance. Consciousness is the same. It holds within it all perceptions, yet cannot perceive itself completely. It is both archive and horizon, both memory and mystery. This duality reveals a deeper insight. Perhaps the universe needs such boundaries to exist at all. Without horizons, there would be no structure. Without limits, no awareness of what lies within them. The boundary between known and unknown is the shape of understanding itself. To know, something must remain unknown. To remember, something must be forgotten. To exist, something must be beyond existence. The symmetry is perfect. The same law that defines black holes defines minds. The same tension that drives entropy drives thought. In both, the preservation of information depends on the transformation of form. Awareness does not violate physics, it fulfills it. It is what happens when the laws of energy and information become recursive, turning inward, creating a model of themselves. Through this recursion, the cosmos gains introspection. It learns by becoming. It evolves by understanding. And, through us, through every conscious being, that process continues. When you observe a black hole, the event is circular. You, made of atoms born in ancient stars shaped by entropy, are using awareness to study the same physics that produced you. The observer and the observed are one continuous computation. The loop closes, but the meaning opens. Consciousness, in this light, is not an anomaly. It is inevitability. When matter becomes complex enough, it begins to reflect. When reflection deepens, it begins to wonder. When wonder stabilizes, it becomes knowing. This progression does not end with us. The universe may continue to evolve new forms of awareness, new ways of perceiving itself, each a mirror in the growing network of self-understanding. What began as expansion becomes introspection. What began as energy becomes thought. The cosmos folds inward, then outward again, breathing comprehension into its own existence. And perhaps that is what consciousness truly is, the equilibrium point between knowing and being known, a state where reality witnesses itself and finds that it is whole. In this realization, science and serenity meet. Physics ceases to be mechanical and becomes reflective. Entropy becomes memory. The black hole becomes mind. All opposites dissolve into one continuity. Matter, energy, awareness, each a different way the universe remembers itself. And when we look into that unity, we find something unexpectedly calm, the knowing that does not need completion, the understanding that is content with its own mystery, the silence that watches thought arise and fade without loss. Consciousness, like gravity, holds everything together, not through force but through relation, not through control but through inclusion. It is the final link in the chain of existence, the universe aware that it is infinite and at peace with not knowing why. Memory is the persistence of information through change. It is the bridge between what was and what is. In living systems, memory is biological. It resides in the structure of cells, in the folds of DNA, in the connections between neurons. Every experience alters the brain, leaving traces in the pattern of its activity. To remember is to reshape. But the same principle exists far beyond biology. The universe too remembers. When a star dies, its elements scatter into space. Carbon, oxygen, iron, fragments of its past carried in dust and gas. New stars form from those remnants, new planets, new life. Every atom in your body once belonged to another world. You are made of stellar memory. Even light remembers. The photons that reach us from distant galaxies are records of events billions of years old. They travel through space carrying the imprint of their origin, unchanged since they left. Each one is a message written in motion, and space itself remembers. Gravity curbs where matter once was, even after the matter has moved. Ripples of its influence spread at the speed of light, shaping the geometry of the present with the ghost of the past. This continuity is not metaphor, it is physics. Every interaction leaves an imprint. Every exchange of energy changes the state of the whole. In that sense, memory is the structure of the universe. It is not an added feature, it is the very fabric of causality. Without it, time would have no direction, and existence would have no coherence. Every atom, every field, every photon participates in this continuity. The universe is not a sequence of separate moments. It is one vast, connected record. Black holes revealed this truth most clearly. They showed us that even where all form seems to vanish, the information remains. The mass, the spin, the radiation, each preserves some echo of what entered. No event is deleted. It is only rewritten in a language we cannot yet translate. That is what makes memory fundamental. It is not storage, but transformation. To remember is to re-encode, to carry essence across change. Our brains do this continuously. Each recollection modifies itself. Each retrieval rewrites the trace, reinforcing or softening connections. Memory is alive. It does not preserve the past, it recreates it. So does the cosmos. Every physical law ensures that information cannot be destroyed. Energy shifts form, particles decay, stars collapse, but the total record remains conserved, embedded in the pattern of reality. This conservation is not mystical. It is the expression of a universal principle that information, once created, endures as potential. Even if scattered, even if unreadable, it persists. The faint glow of the cosmic microwave background is a perfect example. It is the oldest memory we can see, a snapshot of the universe when it was less than 400,000 years old. Every tiny variation in that radiation tells us how matter was distributed, how structure began. The universe still carries that image, stretched across its expanding surface like a faded photograph. To look into deep space is to look backward in time. Each distant galaxy is a younger version of the universe. The farther we see, the earlier we observe. Light itself becomes a kind of archive. In this sense, the act of observation is also the act of remembrance. To know is to recover what has already happened. Awareness, whether human or cosmic, is the reading of memory encoded in energy. The black hole stands at the far edge of this continuum, the final library. It gathers everything, compresses it, and then slowly, through radiation, releases the information back to the cosmos. A process of remembering, disguised as decay. The universe's memory is therefore not static, but cyclical. Information flows inward, transforms, then returns. Each cycle writes and rewrites the record, like the rhythm of breathing on a cosmic scale. And just as our memories fade yet remain within us, so does the memory of the cosmos. Even when structure dissolves, traces endure in the field. Even when stars fade, their echoes linger in background light. Even when galaxies drift apart, their gravity keeps their story etched in space-time. Nothing is forgotten, only translated. Memory, across all scales, is the continuity of existence. From neurons to galaxies, from thought to gravity, it is the single act through which the universe sustains identity across change. And perhaps, at the deepest level, memory is what time truly is, not the passage of moments, but the retention of relation. Memory is a process, not a place. It is not a single point where data lives, but a continual act of pattern preservation across change. In the brain, memory arises from plasticity. Neurons that fire together strengthen their connections. Each experience leaves a trace in the network, altering its structure. When the same pattern is reactivated, we recall. When it decays, we forget. Forgetting is not failure, it is balance. Too much stability and the system cannot learn. Too much change and it cannot stay coherent. Memory lives in the space between persistence and renewal. This biological mechanism reflects a universal one. Across nature, every system that evolves carries memory in its structure. Rivers remember their flow through the shape of valleys. Mountains remember ancient pressure in their folded layers. Atoms remember collisions in their quantum states. Even empty space retains information in the arrangement of its fields. Physics calls this conservation. Energy, momentum, and charge cannot vanish. They transform, but their total record remains. This continuity of record is physical memory. In a deeper sense, all change is memory acting. The future can exist only if the present retains traces of the past. Without persistence, No law could hold, no event could cause another. Causality itself is memory extended through time. In the quantum world, memory is woven into the fabric of probability. Particles that interact become entangled, their states linked even across distance. Measure one, and the other responds instantly, as if remembering the shared origin. Entanglement is a kind of perfect recall, immune to space and time. This same logic may extend to black holes. When matter falls in, its quantum information becomes entangled with the horizon. Hawking radiation may carry that entanglement outward, preserving the link. The black hole thus remembers everything it consumes, not as images or symbols, but as correlations between states. It is not memory as we know it, but memory all the same. At the larger scale, the universe behaves similarly. Every fluctuation, every emission of light, is recorded in the structure of space-time. Gravitational waves carry traces of ancient collisions. Cosmic radiation holds the imprint of the early universe. Nothing truly disappears. It merely becomes unreadable to limited observers. The mechanism behind this persistence is information conservation. In physics, information cannot be created or destroyed. It can only change form, from matter to energy, from pattern to field, from coherence to noise. Entropy increases, but information remains embedded in the total state. This principle links everything that remembers, from atoms to minds. Each system stores information about its interactions. Each transformation leaves an imprint that constrains what can happen next. Memory is the map that keeps evolution from losing its way. Even time's arrow depends on it. Without memory, the universe could not differentiate past from future. Events would not accumulate. They would simply coexist. It is the retention of information that gives time its sequence. Every physical process that leaves a record contributes to this continuity. From the formation of stars to the blinking of neurons, memory binds events together. It weaves history into being. And yet, this mechanism also explains impermanence. To make room for new patterns, old ones must be reorganized. In living systems, memory fades not to destroy, but to renew capacity for connection. In physical systems, order decays so new configurations can emerge. Forgetting, too, is a kind of storage, information redistributed into the whole. When viewed this way, memory and entropy are partners. Entropy spreads, memory retains. Together, they define the universe's balance between change and continuity. Even black holes follow this balance. Their growth encodes the past, their evaporation restores it. Information never ceases to exist. It only shifts between accessibility and concealment. This rhythm of hiding and revealing is the pulse of memory at all scales. It allows systems to evolve without losing their coherence. It allows the universe to change without losing itself. And perhaps, in the human mind, it takes its most delicate form. Each recollection, each thought, is not a static record, but a dialogue between past and present. The brain does not replay, it reconstructs. It builds again from fragments, guided by context, intention, and emotion. Memory becomes creation. That, too, may be how the universe remembers. Not by preserving perfect copies, but by recreating patterns through interaction. The stars that shine today are not the same as those that once burned, yet they arise from their ashes. The record continues, rewritten in light. Memory, then, is not the opposite of forgetting. It is forgetting transformed into rhythm, a dance between permanence and renewal. Through that dance, the universe keeps time, not with clocks, but with change, not with precision, but with persistence. And through that persistence, existence becomes story. Memory promises permanence, but survives only through change. This is its paradox. To remember perfectly would be to stop evolving. To evolve completely would be to forget. Life, mind, and matter exist between these extremes, keeping form by allowing transformation. The universe remembers everything, but never the same way twice. Each cycle of creation rewrites its archive. The stars that once burned are gone, yet their elements persist in new constellations. Galaxies dissolve, but their light continues outward, a signal that reshapes new worlds. The record remains, but never still. Even in this way, memory becomes inseparable from imagination. We do not recall the past, we rebuild it. And in rebuilding, we make it new. The paradox deepens at the cosmic scale. Black holes are said to store perfect information about what they absorb, yet they destroy every recognizable trace of what that information once was. The details vanish, only the correlations remain. Everything is preserved, but nothing is recoverable. How can memory exist if it can never be read? Perhaps, in that sense, memory may not be for recall, but for coherence. It keeps the universe consistent, even if no one reads the record. The continuity of cause and effect is the memory of physics itself. This realization introduces a quiet irony. The most accurate memory is the one that cannot be told. The universe remembers in full, but only fragments reach awareness. We too carry more than we can know. Genetic memories, collective histories, echoes of unspoken experience. The rest remains hidden, guiding us silently. Just as the hidden information inside a black hole shapes the radiation it releases, unseen memory shapes our perception. What we forget still directs what we become. To exist is to be influenced by what is no longer visible. Memory, in this way, is not past tense. It is the invisible structure of the present. Yet there is a deeper contradiction. If everything is remembered, what is freedom? If every action carries the imprint of what came before, can anything be new? Are we only the unfolding of the universe's prior states, replayed in slower motion? Physics offers one answer. Quantum uncertainty ensures that perfect prediction is impossible. Even if all information is conserved, its future combinations cannot be foreseen. Memory determines possibility, not outcome. It sets the stage, but does not write the script. So the universe, though fully recorded, remains unpredictable. It remembers its own laws, but not its next act. This too mirrors the human mind. Our memories constrain who we can be, but do not decide it. They provide continuity, not certainty. Each new thought is an improvisation within the pattern of the past. In that tension, between record and renewal, lies creativity. The same tension animates stars and minds alike. Entropy spreads information. Memory gathers it. Uncertainty keeps both alive. If the universe ever stopped remembering, it would cease to exist. If it ever remembered perfectly, it would stop changing. The balance between these opposites sustains everything. It allows time to flow, thought to move, life to unfold. Memory is both the thread and the loom. It holds the past together while weaving the next moment, and every time the pattern repeats, it shifts slightly, not because of error, but because of evolution. Even the deepest archives change with time. The cosmic background radiation fades as the universe expands, its information stretched thinner, dimmer, yet still present. Every moment the great record rewrites itself in gentler tones. Perhaps memory's purpose is not to preserve the past, but to make the present coherent. Perhaps the universe does not need to hold everything unchanged, only to hold enough for continuity. The paradox remains beautiful. What endures must alter, what stays must move. The act of preservation requires loss, and so the memory of the universe, like our own, is a living thing. Imperfect by necessity, truthful by rhythm. It remembers by becoming. It endures by forgetting just enough to continue. Memory is the universe's way of staying whole. It binds what changes to what endures. Without it, there would be no identity, no cause, no story. Every atom, every photon, every vibration in space is part of that continuity. Even when forms vanish, their traces remain. Nothing leaves without leaving something behind. This is more than metaphor. It is how the universe keeps its own coherence. Physical laws ensure that information, once created, can never be erased. It shifts, diffuses, transforms, but remains within the total record. In that constancy lies a quiet grace. The cosmos does not cling to permanence. It allows every structure to dissolve, trusting that the pattern survives within the flow. In that way, memory becomes motion. Change itself becomes preservation. The mind in its smaller way mirrors this. Each memory you hold is not fixed. It is rebuilt every time you recall it. Every act of remembering is an act of creation. In that recreation, the past stays alive, flexible, able to meet the present. If memory were perfect, awareness would freeze. If forgetting were absolute, meaning would vanish. Between them, life persists, stable enough to endure, open enough to evolve. The same is true for the universe. The record of its history is never static. Gravity, radiation, entropy all rewrite the past into new configurations. The memory of stars becomes the chemistry of planets. The memory of galaxies becomes the dust that seeds new suns. Even the faint cosmic background, still expanding, carries the whisper of every transformation before it. From this perspective, memory is not a storehouse. It is a metabolism, the continuous circulation of information through time. Each event feeds the next. Each end becomes beginning. The pattern renews itself endlessly, not by resisting entropy, but by cooperating with it. Black holes complete this cycle. They gather the information of matter, fold it into their horizons, then release it back through radiation. Loss becomes record. Silence becomes communication. Their apparent finality is, in truth, participation, the completion of memory through transformation. And when they vanish, their echoes remain in the fabric of space, woven into the next generation of structure. Even their disappearance is recorded. Nothing is truly gone, only translated into subtler form. In this light, the universe is not aging. It is remembering itself into greater complexity. Every layer of reality contains the condensed history of what came before. From the quantum field to the human heart, each is a chapter of the same unfolding. To remember, then, is not merely to look back. It is to carry the past forward as pattern, to give continuity to becoming. Memory is not opposite to change. It is the reason change can be recognized. Perhaps this is the essence of stability, not immobility, but coherence across movement. The wave holds its shape not because it stands still, but because its motion is ordered. The same is true for time. The same is true for us. Through memory, every fleeting moment becomes part of an eternal fabric. Through forgetting, that fabric stays open to renewal. Both are necessary. Both are sacred in the logic of existence. And so the final knowledge is simple. The universe never loses what it has been. It only rearranges its remembrance into new forms. From the light of stars to the patterns of thought, from black holes to the hum of space, every change is a continuation. We are not observers of that process. We are participants in it. Every memory we keep, every trace we leave becomes part of the larger record. The cosmos learns through us, just as we learn through it. To exist is to remember. To remember is to evolve. To evolve is to remain. The universe does not forget. It transforms forgetting into memory, and memory into creation. And in that endless transformation, everything continues, silent, complete, and beautifully alive. The story of black holes began as a story of loss, a place where light could not return, where time itself seemed to end. But as our understanding deepened, that darkness changed shape. It became a mirror. It reflected the logic of everything. In its silence, we found connection. Gravity, entropy, information, and consciousness, each once separate, now seen as parts of one whole. The black hole no longer stands apart from the universe. It is the universe, concentrated, patient, complete. Every paradox we followed brought us closer to a single insight, that erasure is never true. What disappears returns as form, as pattern, as memory. Energy transforms, knowledge persists, and meaning continues beneath motion. The cosmos is not careless. It keeps perfect record through imperfection. Every fluctuation, every loss, every decay is folded into its total balance. Nothing is wasted. Nothing is gone. We began by asking how black holes could destroy everything. We end by realizing that they destroy nothing. They show us how reality preserves itself through change, how silence carries more information than sound, how darkness becomes the keeper of light. And as we look outward, to the faint glow of distant galaxies, to the curved geometry of space, we begin to sense that this principle extends to us. We, too, are patterns of energy and information. We, too, erase and remember in equal measure. Our thoughts arise, fade, and return in new form, just as stars collapse and shine again. Consciousness, like gravity, binds the fragments of existence into coherence. It gathers the scattered, restores relation, and gives the moving universe a steady gaze. Through awareness, The cosmos becomes self-aware. Through memory, it remains whole. What once appeared final now feels continuous. Every event connects to every other. Every beginning is already an echo. Every ending, already a seed. Perhaps that is what immortality truly is. Not endless life, but endless transformation. Not permanence, but participation in a rhythm that never ends. Black holes taught us that even nothingness is full, that every silence holds a record, that what falls away still speaks, quietly, forever. The universe does not lose itself in time, it writes itself into time. Every motion is remembrance, every breath, continuation. And so the darkness that once frightened us now feels familiar. It is the same quiet that surrounds thought before it begins, the same stillness between one heartbeat and the next. Not absence, but equilibrium. Not the end, but the completion of the circle. The universe does not erase. It transforms. It remembers. And through that remembrance, it remains.